All right, guys, so this is the quiz remediation for free fall. So we're going to go through a problem, and then I'm going to ask you some questions at the end. So, free fall. Justin Bieber is thrown up off of a 200-meter cliff at 3 meters per second. So, thrown vertically straight up. How long is he in the air, and how high does he go? So, pause and write this down because I'm going to minimize it a little bit. All right, so if we draw a picture of this situation, I've got a cliff here. Justin Bieber is being thrown vertically straight up, and he's going to come back down. Okay, so he'll follow a path like that, assuming no angle. I know we're talking about projectiles now, but this is back from when we're just talking about free fall. So we know some things about him. So we know his initial velocity is a positive 3 meters per second. We know his delta y eventually at the very end will be negative 200 meters, right? Because he's going to be thrown up, but he'll eventually go down this distance. Time is what they're looking for. It's his total time in the air. And then they also, the second part of the problem is how high is he at the very top of his path. So we also know acceleration's negative 9.8 meters per second squared. So I can go ahead and solve this first question. So I do not know final velocity. So I'm going to use this equation, delta y equals 1/2 at squared plus tv naught. So I plug in negative 200 equals 1/2 times negative 9.8 times time squared plus time times 3. All right, so we've run into a quadratic, right? So I've got time squared and time. So the only way to solve this is to either use another equation, solve for final velocity, or to do a quadratic. So let's find the final velocity. So his final velocity is question mark. We can do v squared equals 2a delta y plus v naught squared, right? So that equals 2 times negative 9.8 times negative 200 plus 3 squared. If I put that in a calculator, I get v squared equals 3929. Now I'll take the square root of both sides. I get 62.7 meters per second is his final velocity. All right, so instead of using this equation, now I'm going to go ahead and do v equals at plus v naught. Okay, I know v, I know a, I know v naught, so 62.7. And actually, it should be negative, right? If we think about that, he's moving in the negative direction before he dies at the bottom. I don't have anything against Justin Bieber, I swear. Times time plus 3. So negative 62.7 minus 3 divided by negative 9.8. And you get a time, he's in the air for 6.7 seconds. That's a long time. All right, how high does he go is the second question. So I'm going to try and make room for this over here. How high does he go? So at the top of his path, that's the neat point where we know that his final velocity is 0. Okay? His initial is still a positive 3, acceleration still negative 9.8. We don't know time, and we don't know how high he goes. So if they're just asking how high he goes, I'm going to use v squared equals 2a delta y plus v naught squared. All right, so I plug in final velocity 0 squared equals 2 times negative 9.8 delta y plus my initial velocity, which is 3 squared. So I get negative 9, because I move this to the other side, and then divide by negative 4.9. And your delta y is 1.8 meters. Okay? That all comes from using this idea right here that at the top the final velocity is 0. All right. One more thing I want to emphasize that I think wasn't fully emphasized is that if you get a problem, I'm going to draw right here, where it's launched from one height and comes back down to the same height, the velocity right here, your V naught, is going to be equal to your final velocity, okay? Velocity at the top equals 0. We emphasize that point a lot, but the initial velocity and final velocity are equal and opposite. All right, you're going to answer some questions, and then you guys are good to go.